When you think of personalization, you think of user personalization. Each user should have his own recommendation, right? We know exactly how to do that. Group users according to similar preferences and fill the gaps based on users that are close to you. In the Netflix example, items were movies. To measure similarity between users, we compute inner products between two profiles of users, that is, two rows in the matrix. The main limitation of this approach is that these rows are mostly empty. Each user has rated a very small fraction of movies. We end up multiplying a lot of true ratings by our artificial rating, 3, that we used as a placeholder for empty entries. Recall this example. Here, about half of the entries were missing, the red entries, and that's where we put a 3. In practice, we color code black for a present entry and red for a missing entry. The picture looks much more like this. It's a drop of black in an ocean of red. This has pretty drastic consequences when we're taking inner products. Let's try to align two such rows on top of each other. As you can see, there's very few overlap between the black present entries. To measure the extent of this problem, we need a better understanding of how missing entries are distributed across the matrix. How are these entries filled and spread across the movies? Did some users rate more movies, or did they all rate pretty much the same number of movies? Were some movies rated much more than others? To answer these questions, let us look at some data. Let us start with the number of ratings per users. As we can see, it has a really long tail. A few users rated up to 40,000 movies, but most of them rated a much smaller number of movies. This image is consistent with having each user rate each movie at random with probability 1.2% independently across users. In technical terms, this looks like a Poisson distribution. How about the number of ratings per movies? This is essentially the same phenomenon. A few movies have received up to 250,000 ratings, but most of them have received very few ratings. The most rated movies include Miss Congeniality and Independence Day, for example. The impact of the second plot is much more drastic, though. Indeed, if a few movies have a lot of ratings, then they're probably popular, which in turn means that they are likely to be watched and then rated. Therefore, it makes sense to focus our efforts on these movies. For these movies, we have a lot of ratings, and therefore we can take the inner products between columns rather than rows. It has a significant advantage over taking inner products between rows. There are many more collisions. Let's make a quick calculation. The proportion of entries that are filled for the movies Independence Day and Miss Congeniality are about 250,000 divided by 500,000, which is about 1/2. Therefore, if we place the two columns next to each other and compute their inner product, we can estimate the number of collisions as follows. We have 500,000 times 1/2 for the first column and 1/2 for the second column, which is 125,000 collisions. That's a lot. And the good news is that we'll get a large number for most of the popular movies. In turn, this means that we'll have a much more accurate measure of similarity between popular movies. So rather than doing user personalization, we can do item personalization. And it's exactly the same picture as before. If Dirty Dancing gets ratings that are similar to Ghost, for example, then the missing entries for Ghost should be close to the entries for Dirty Dancing. As we'll see in the case studies, this item-based personalization is much more predictive than the user-based ones, for exactly the reason that we mentioned before. The movies that really matter have a lot of ratings.